Alright, testing, testing. Alright, chapter 6. Section 5. Expansion, contraction, and welding operations. General. Most of the welding process involved with the heat, the high temperature responsible for much of the welding warpage and stress of the curve of the welding metal is heated, expands in all directions. The welded metal cools and contracts in all directions. Some distortion causes with welding shrinkage and shown in Figure 642. Vertical welded pulled off the center, flat work pulled off the out of line, flat work drawn into the curve, spacing closes. Alright, there's no direct relationship between the amount of the temperature change with the change in the dimension of the base of the efficiency of the thermal expansion. Thermal expansion is measured with a linear increase for the unit length based on the change of the temperature of the material. The coefficient expansion of the different of the various metal, but the aluminum has one of the highest coefficiency with the expansion of the ratio changes in dimensions almost twice as much as the steel is the same temperature. The material expand with the contract same amount of the heat and cool with the same with the temperature of the downward strain with the expansion of the part of the being welded, restrained, backling, or warping may occur with the contraction or restrained with the part that may be cracked or distorted with the shrinkage stress. When welding metal with the heat with the cool with the not unrestrained since they are more part of a larger piece of the metal which is not heated with the same with the temperature parts not heated with the not heated as much of the tend to restrain with a portion of the same piece of the metal with the heat with the high temperature of the non-uniform heating of the always occurs in welding. The restraint caused by the part being non-uniformly heated with the principal cause of the thermal distortion of the warpage of the curve of the welding. Residual strength occurs when the metal is subject to the non-uniform temperature of the cause of the thermal strength of the stress of welding and have the two major effects of the produce the distortion that may cause the premature failure in weldments. Controlling contraction sheet metal of the welding procedure should be divided with the contraction stress, which will be held with the minimum in order to keep the desired shape of the strength of the weld with the sum of the method that used for the controlling of the contraction described below. The backstep method shown in view A with the figure 643 may be used with the backstep method. Each small welding increment has its own shrinkage pattern, that becomes insignificant to the total pattern of the entire weldment. 643 shows the method of the contraction part. The welded place approximately 18 inches ahead of the welded direction weld with the contraction points of the weld. The direction of the electrode with the average length, average 8 to 10 inches direction of the weld. Contraction over the sheet metal. Then welding long tube with the contraction of the metal deposit with the joint with the which will cover the edge of the weld as they draw together positively overlap. This action should be offset with the welding edge of the part shown view B with the figure 43, page 639. The weld should be removed forward as the weld progresses with the spacing of the weld dependent on the type of the material and thickness. Spacing of the metal with more than 1/8 of an inch of the thickness approximately as follows: steel 1/4 to 3/8 of brass, bronze 3/16, aluminum 1/4 to copper 3/16 of an inch, and lead 5/16 of an inch. Sheet metal under 1/16 of an inch may be welded with the flange edge of the shown figure 620 and through page 623 with the tack of the intern along the seam of the before the welding. Weld can produce the span without addition of the filler metal. The buckling and the warping can be prevented using quenching plates as shown figure 644. Quenching plates are a heavy piece of the metal clamp parallel to the seam being welded with sufficient space between them to permit the welding operation. These quenching plates absorb the heat of the welding, thereby decreasing the heat and stress due to the expansion and contraction. Shows the sheet metal of the quenching plates and the milled groove in the sheet metal. Alright, jig fixtures may be used to hold the member of the placement for the weld, but they usually heavy section of the vicinity with the seam, the heavier section of the blade with the beyond the area of the weld. Figure 645 shows the fixture of the sheeting metal with the sheet metal with the moving the bracket of the hinge. And pipe welding spacing with the illustrated figure 643, page 639. It's not practical with the proper alignment of the pipe is best to obtain with the tack of the welding holding the pieces in the place of the pipe should be placed. Piece separated with a gap of 1/8 to 1/4 of an inch, depending on the side of the being welded. Controlling contraction expansion of the casting. Prior to the welding, gray iron casting expansion with contraction provided with the preheating before welding the small casing with the preheated mains of the torch. Very dull red hot, visible in the darkened room. After welding, the reheating and controlling slow cooling and annealing will relieve internal stress of the proper gray iron structure. Larger casting, temporary charcoal-fired furnaces built with the fire brick and the cover with the fire-resistant material are often used. Only local preheating of the parts adjacent to the weld that usually necessary. Such local preheating can be done with a gasoline, kerosene welding torch. Figure 643 shows the controlling expansion of the casting and the preheatings. 627, controlling contraction expansion of the casting continued. Before welding a crack extend with the edge of the casting and the divisible drilling a small hole 1/2 to 1 inch Beyond the visible end of the crack of the ply with the heat of the cover of the crack to run, the visible will only extend with the drill of the hole. The crack does not extend with the end of the casting advisable. The drill with a small 1/2 to 1 hole inch beyond the end of the visible crack. Above the procedures applied with the gray iron casting as well with the bronze welding casting, especially with less required for bronze welding casting. Alright, 628, welding, distortion, and warpage. General high temperature involved with the most welding the process of the larger responsible for the distortion, warpage, and stress that occurs when the heated metal expands with all the directions, while it cools, it tracks all directions. The described in paragraph 625 of the direct relations between the amount of the temperature change with the dimension with the metal with the expand with the contract with the small, same amount with the heat with the cool with the same temperature, the not restrained with the power with the welding in the metal with the preheated and cooled unrestrained because they are a large part of the piece of the metal, piece of partially restrained with the main with the cover of the thermal distortion, warpage of the curve of the welding. Figure 647 shows the effect of the expansion of the cubic metal with the cubic metal will expose with the temperature increase. It will expand in XYZ direction which cools when it cools. If unrestricted, will contract the same amount as it expand. Alright, a weld is usually made progressively to cover the solidified portions of the over the weld, resist for the shrinkage later portion of the welded bead. The portion of the weld, the first of the force and the tension down with the length of the weld, the bleed longitudinal of the weld, the shown figure 640 with the case of the bolt weld, little motion of the weld that is permitted with the direction across the material face of the transverse direction with the cover of the weld, the joint preparation, stiffness effect, underlying passages in these welds, shown figure 648. This will be the transverse residual stress, and then the fillet weld, shown figure 649 with the shrinkage stresses, ridge down length of the weld and across its face. Our 648 shows longitudinal transversal stress in the butt, and longitudinal transversal shrinkage in the fillet weld. At the point of solidification, molten metal with a little or no strength that is equal with the squares of the strength, but they also expand with because of the high temperature weld metal not used for the base metal with the work. Together, the metal continue with the cool with the required with the higher strength than known with the contracting in these three dimensions of the arc. Depositing molten metal is moving the source of the heating with the cooling differential is also the moving factor, but tends to the flow and the travel over the arc. The temperature for the such decline each of the small increment of the heated metal depending on the contraction stress which will occur with the weld and the movement of the metal adjacent to the weld. Unheated metal tends to resist the cooling dimension of the chain of the previously molten metal with the temperature differential as an effect on this. The temperature for the differential is determined by the thermal conductivity. The higher the thermal conductivity of the metal, lesser differential heating will have. For example, the thermal conductivity of the heater of copper is the highest. Aluminum is half of the amount, and the steel the 1/5 of that of the copper. Heat would move more quickly through a copper bar than in a steel bar, and the temperature differential would not be so great. Physical property of the may be considered for the welding, along with the fact that the arc temperature of the very similar with the metal, with the melting points is somewhat different. Another factor, the travel speed of the heat short for the arc of the travel the speed with a relatively fast shaft effects of the heat of the arc that will cover the expansion of the edge of the plate. This will blow outward to open up the joint, and this is the same in the running of the bead with the edge of the plate with any other case of the momentary simultaneous situation with continuous to change the welding progress is by adjusting the current with the travel speed. The exact speed can be determined by the specific joint with the design of the root when either open or nor closed together. Welding, distortion, and warpage continue for F. The residual stress of the weldment that produces distortion may cover the immature failure of the weld, and the distortion cover the heave of the weld. The region contracts non-uniformity cover the shrinkage of the one part of the weld. Exert eccentric force on the weld with the cross-section welding strains elastically in response to the stress of the non-uniform strain with the macroscopic distortion. The distortion may appear with the butt joints of the longitudinal transverse shrinkage of the contraction of the angular change rotation when the face of the weld with the shrink of the more of the root, the angular change of the produce of the transverse bending of the plates along the welded length with the effects of the shown figure 650. 650 show the disbursement of the butt weld. Distortion of the butt weld. Distortion of fillet welds are same with the butt weld with the transverse longitudinal strength of the angular distortion result of the unbalanced nature of the stress of these butt welds. Figure 651. Since fillet welds are often used for the combination of other welds with welding, the distortion may be complex. 651. Distortion of fillet weld. H. Residual stress. Distortion effect of the material with the contraction of the buckling, curling of the fracturing, lower applied stress level. The residual stress of the company with the distortion present with the backing of the main curve with a long linear composition For linear compressive loads that would be predicted otherwise, intentional residual loads may be delayed with a high local stress of the welded region. Low tensile, low toughness may result in the running of the brittle cracks, which can be spread to low overall stress area, but the residual stress may also contribute to fatigue and the corrosion failures. Controlled distortion can be achieved with the several method, commonly used the method of control of the geometry welding joint, either more before or during welding. Must include prepositioning workplace before the welding and the welding distortion, leave them with the desired final geometry with a restraining workplace that cannot be moved. The distortion of the welding design. The joint with the welded deposits are based on balance, and each side with a center line with another. Usually, technically, the welding process, the selection welding sequence, the influence of the distortion residual stress. Some distorted welds can be straightened mechanically after welding. Thermal or flame straightened can also be applied. Residual stress may be limited both thermal and mechanical means. Thermal stress relief of the weld is achieved with the temperature at which the yield point of the metal was low enough to the plastic flow with the curve of the weld, with the relaxation of the stress. Mechanical property of the weldment may also obtain, but not also toward the more uniform distribution across the joint. For example, the brittleness fracture of the resistant may steel weld rents improve the steel thermal stress relief, not only because of the residual stress of the weld reduced, but also with the reduced the hard affected heat affected zones are tempered to be made tougher and produce future mechanical stressing relief temperatures. Treatments will reduce the residual stress, but will not change the microstructure hardness of the weld heat affected zone. Painting of the proofing, stressing, other techniques are applied to weldments to accomplish these ends. Okay, the welder might consider not only reducing the effect of the residual stress of distortion, but also reduction of the cracks, porosity, other discontinuity, material degradation of the thermal effect during the welding, the extent of the non-destructive testing, fabrication cover the process of the procedure for the produces less distortion, may also produce the porosity and cracking of the welded zone. Warping distortion may be minimized with several methods. The general method include the reducing residual stress and distortion prior to the welding, selecting the process of the procedure, the developing of the better means, but the other stress relieving the remove of the distortion. Changing the structural design of the material so that the effect of the residual stress and distortion may be minimized. Following factors can be taken into consideration when welding in order to reduce the welding warpage. 1. The location of the neutral axis of the relation for the both direction. Location of the weld side of the weld. The distance of the neutral axis in both directions. Time and the factor of the welding. Cooling rates of weld making the various welds. The opportunity of the balance welding the neutral axis. Repeated industrial structure varying with the welding techniques based on measurable warpage. The use of procedure sequence minimize welding distortion. The welding large structure weldment is important to establish procedure for the minimizing of the workage in order to join the plate of the deck with the tank of the wheel. The effect of the traces distortion. General rule: the transverse welds should be made with before longitudinal weld. Figure 652 shows the order which the joint should be made. Warpage may be the smaller structure of the different techniques in which will include the following: use of the restraining fixture for the strong back with the main attack, the use of the heat sink for the fast cooling weld with the redistortion, pre-bending of the parts being welded, balancing welds over the bout with the welded neutral axis while using watering of the sequence of the back with step welding, use the intermittent welding to reduce the weld of the welded metal, use the proper joint design selection to minimize the weld and last distortion, resort and preheat and post preheat and painting. Section 6, Welding Problems and Solutions.